Okay, so we're going to transition topics and we're going to lead into a short topic on statistics and data. It does tie into what we have been doing because how we can interpret this data, we use linear functions. So let's go first see what is a scatter plot. Well, a scatter plot is a graph, okay? It uses points to display numerical data, okay? And it's numerical data that has two different variables, which we call bivariate. So we would use a scatter plot when we are surveying and we're collecting, and the result of our questions would result in two different numbers or even possibly the same numbers, but the two concepts are different. So scatter plots can help determine if one variable has an effect on the other, or if there are overall trends. So this helps us to interpret and predict. And it's going to help us, we look at patterns or correlation between the variables. What I want you to do is write under the word correlation, you need to write the word association, because you will see and you will hear us use the same word, that word interchangeably. So if you hear us say correlation or you hear or read association, they mean the same thing. Okay, so let's go look at what this is. So this is a scatter plot. This is what they look like. And what happened was, in this situation, shoppers were surveyed at a mall, and they were asked how many items purchased, so the result would be a number, and what was their total amount of money as a result of what they bought. So what we have to know is when we look at a scatter plot, each point represents someone that was asked the questions. So if we wanted to know how many people Susie surveyed, we would just count each point. So in this one, there were 16 people. So what we can do is we can make predictions and we can look at patterns and we can answer this next question. Does the number of items purchased seem to have an effect on the amount of money they spent? Well, if we look, it almost looks like as they bought more items, their total amount of money spent went up. Yes, there are some cases that they overlap, but overall, and that's what we make a generalization. Overall, it appears as though the people who bought more spent more, which makes complete sense. So we need to be able to interpret this data. So when the two things have a positive association, the variables move together, meaning as one variable increases, the other increases. And if you look at the picture, that's what's happening. A negative association means that they move in opposite directions. So as one variable increases, the other variable decreases. Our third type is called no association, meaning they don't relate to each other. There is no effect on the other one, okay? So let's think about these situations. Remember, we want to determine if it's a positive, negative, or no association. The hours a person studies and the number of states they visited. Would studying more change how many states you visit? No, there's no correlation there. Okay, so let's think about this one. The hours a person studies and their grade on an exam. So remember our types. Positive, they both increase. So if I'm spending more time studying, my grade's going to go up. A negative is as one increases, the other decreases. So put it in that situation. If I spend more time studying, my grade's going to go down. Does that sound right? No. So this should have a positive correlation. And then last, the hours a person studies and the hours they spend watching TV. Well, let's think about this. If I'm studying more in one night, the amount of time I have left to watch TV goes down. Okay, so that would be a negative correlation. So another way and another part of interpreting this data is if we can draw a straight line to follow the overall trend, then we would say the scatter plot is linear. if the points of data are close together, the association's strong. That means that correlation, that association that they have with each other, it's a strong. But if the points are spread apart, it's a weak correlation. So let's go look at these 6 graphs, right? Here's the first 3. If I look at number 1, I could draw a straight line through that. So it would, and it's going up, so it would be a positive, strong, linear association, okay? I can draw a straight line, and the straight line I would draw would be going up. All those points are close together, so that's why it would be a strong one. So let's go look at our next one. So you can still have a positive association, it's going up. But the points are more spread apart here, so it's a weak. But again, it is linear because they're basically forming a line. Number 3, though, kind of has a similar trend. It's going up, so it's positive. They are close together, so it's strong, but it's a curve, so it's nonlinear. Okay, so let's look at number 4. We should be seeing this already. It's a negative, okay, but it's strong because they're close together, and it's linear because it kind of looks like it forms a line. So number 5, we see the negative trend. We see it going down. We see that they're somewhat spread apart, and there's a bit of a dip to it right there in that middle, so it's nonlinear. Well, number 6, there's no correlation. There's no association. They're all scattered everywhere. And it's weak because they're all spread out. And 100% it's nonlinear because they do not come together to form a line. Okay? So let's think about what type of association this would be and explain why it would be that. So a person's height and a person's shoe size. Well, I would go with positive because for the most part, as you grow, your foot gets bigger, okay? Let's look at the next one. The number of letters in a person's name and their IQ. Right, you probably are sitting there saying, how does that relate to that? Well, if that kind of question pops in your brain, it's no association. There is no correlation there because the number of letters in your name has nothing to do with your IQ. Last, the number of absences a student has and a student's GPA. Well, that should signal something to you that, okay, if you're missing more school, right? So you're missing school, meaning the number of absences are going up. But what happens to your grade? It tends to go down. So one's going up, one's going down, so it's negative. Because your grades are going to decline because you're not there to learn the stuff. Okay, so here we are with matching. What we want to do is match the situation to the points. So the way I do this is first determine, is a situation a positive, a negative, or no correlation? So the temperature outside and the total gallons of gas at a gas station. That's not going to have any relationship to each other. So it's just going to kind of be all over the place. So if you look at your graphs, that would be 10, okay? The size of a home and the cost of monthly utilities. Well, if you don't know what a utility is, it's like your electric bill, your water bill, okay? So let's think about this. If you get a bigger house, you have more bathrooms, you have more rooms that you have to keep cool, you're going to be spending more money to do that. So the size goes up, but so does your bill. So that's positive. And that's number 9. So this is what most people do. They just put C and they don't even test it. Because could you have made a mistake on A and B? And the answer is yes. So we go read this one. The altitude of a hiker and the total oxygen. Well, you got to think of real world. As you climb and you get higher, your oxygen levels get smaller. That's why in an airplane, they have those oxygen masks. If they ever lose pressure, you feel like you can't breathe. So that would have a negative correlation, and that is C. Okay, so you got to remember the trends. You got to know what it's looking like, and then we will build on this tomorrow.